Okay. Hello, everyone on the call. This is Dan Reeser from the Web3 Foundation, and I'm joined here by Ivor, Filip, and Bogdan from MVP Workshop based in Serbia. This is basically an online version of the Belgrade, Serbia meetup for Polkadot. We're taking it online, hosting it here on the Polkadot meetup, and I'm guessing it's going to be quite the global audience for this Belgrade meetup, which is pretty cool. We will go into quick introductions from the three guys here, and then I believe Bogdan will be getting started with the presentation. So feel free to ask questions throughout. I think the plan is to save questions till the end, so feel free to put your questions in the Ask a Question box, and we can just go through those with everyone on camera once the presentations are done. So thank you.
Okay, so let me be the first, yeah. So I'm Ivor Jugo. I'm a blockchain researcher at MVP Workshop based in Belgrade. Interesting in blockchain, and really happy to host the first Belgrade Polkadot meetup.
Yeah, let me go next. So I'm a blockchain developer, also from MVP Workshop. And today I'm going to talk a little bit about technical stuff about Substrate, if I can say.
Sure thing. And hi, everyone. My name is Bogdan. I'm one of the co-founders and a distributed systems engineer in Finley. And I'm going to start now, so I'm not going to say what I'm going to be talking about. I'm just going to start that. So I hope you guys enjoy. Ivor, you will need to drop off for yeah, good. Thank you. That's good. So I'll just need someone to tell me if everybody sees my screen. I hope it's okay.
It's good.
Yeah, great. Okay, so a very generic title, but we'll cover a lot in these 10 or 15 minutes or so. So today I'm going to be taking a brief introduction, let's say it like that, into Substrate. But before that, as I mentioned, hello everyone, my name is Bogdan. I've been working on Tenderly for around a year and a half. And Tenderly is a blockchain monitoring and smart contracts platform where we monitor and extract data from different blockchains, and then you can plot that data and use it for developer tooling. And this is important because we worked with a lot of people in the space that have either their private blockchains or side chains and stuff like that. So we had a lot of communication with people spinning up their own change, and actually Substrate is a big player there. So that's why we're talking about this today. So rolling your own chain. A lot of people think when somebody mentions blockchain, they think of Bitcoin, they think of Ethereum, EOS, or whatever else. And those are public blockchains, and they are interesting. But there's actually a really huge benefit of running your own, be it a private one. So let's say, for example, you're building a supply chain thing internally for your huge global company. Instead of rolling, I don't know, MySQL, Postgre, rolling your own blockchain, it makes much more sense because you get so much more out of the box. And right now, or until, let's say, before Substrate and everything else, you could, for example, fork the Ethereum repository, which a couple of projects did. So, for example, we have Quorum, which has like a privacy layer on top of that, and that's done by JP Morgan, for example. We also had things from IBM, so the Hyperledger Foundation, where, for example, we have Hyperledger-based, Goro, and other EVM-based and other language-based blockchains. But today we're here to talk about Substrate, so that's the whole idea. So why is Substrate interesting? And I think it's really interesting because it takes a much different approach than anything else we've seen out there so far. So a thing that's always mentioned when you read about Substrate is that technical freedom is mandatory. And what this means is that, for example, building your own Substrate blockchain can take anywhere. So at most an hour, let's say, where you can basically provide the JSON document and you get like an out-of-the-box blockchain that works really well. But another thing that you can do is use the modular architecture of Substrate and build something much more complex, and you then cater to your use case, let's say like that. So let's see what technical freedom actually means. So when we mention blockchain, we usually think about consensuses, of course. And when you're forking, for example, I don't know, Ethereum, something else, you will get something like proof of work or normal proof of authority, consensus, and stuff like that. But Substrate is actually much more flexible than that. So just out of the box, you get stuff like rhododendron, which is an instant finality consensus, Alrand, which is a probabilistic finality constant block time, which I think is actually used by Colin, if I'm not mistaken, the Colin testing for Ethereum. You can also roll shaft and grandpa, which is a progressive adaptive finality approach to consensuses, and I think this one is used most in the community. The one that I never know how to pronounce correctly, Ivor, let's say like that, which is a like probabilistic finality one. You can even roll, for some reason, proof of work, so similar to ETH hash. And finally, you can even roll your own, which makes a lot of sense if you have like really specific use cases for your blockchain. Now, continuing on, this is really important. So numerous attempts have been made in making like enterprise blockchains friendly to be developed, let's say like that. But Substrate is the first one, at least that I saw, that took a really good stab at it by having an abstract block format. So basically, as long as you implement an interface which exports, I think like 5 or 6 fields, something like that. One of them is parent hash, if I'm not mistaken. You basically get everything working out of the box, and it will get encoded in WebAssembly, and that's it. You have your block format. And of course, we need to save all of that. So again, when you're forking something like Ethereum or anything else, you must use Patricia Merkle tree. But with Substrate, you get the total technical freedom for it. So basically, the answer is any, but the more involved answer is that you could use actually the Ethereum one, so the Merkle Patricia trie. You can also, for example, use the binary Merkle trie, which also ships with Substrate. Or again, as everything with Substrate, you can roll your own. So you can easily develop your own storage layer for all of the crypto-related, blockchain-related data and make it cater to your use case. Now, what about blockchain execution? Again, if, for example, you fork Ethereum, and I'm using this one because working with many clients, we saw that most people take that route first and then see that there are more flexible ways to do it, is you usually end up like with a VM. So in case of Ethereum, you get like the Ethereum virtual machine, which is very opinionated in running stuff, and changing that execution layer is very involved, costly, both in terms of money and time that it takes. But Substrate actually takes a really good approach to this. So Substrate has the most abstract and generic, I mean this in a totally good way, execute block function, which basically takes the block interface that I mentioned before as an input and gives it to your handler. And basically, you do your custom blockchain logic there. So you can build your own VM if you want, or use anything out there existing, as long as you unmarshal or unserialize from the WebAssembly one. So the benefits there are that it's very abstract. It uses WebAssembly to encode the blocks. So this means that you're not restricted to using the languages that somebody else said, but you can use basically any language that has WebAssembly as a build target. So you can use Go, you can use Rust, you can use C++, you can use, I don't know, a couple of other languages, all of them having WebAssembly as a target. So you can basically write your business logic in the language that your company is most comfortable with, and then just build for WebAssembly, and it just works. Now, hot upgradable. What I mean by hot upgradable, we all know about the term called the hard fork. And the Bitcoin space, there have been a couple of ones where we ended up with a couple of versions of the Bitcoin. Also on Ethereum, for example, we had the DAO hack, which was like this huge deal that happened where a hard fork had to be made for something to be changed. Hot upgradable basically means that you can change the underlying business logic of your blockchain that you implemented, let's say, for example, in Go, Rust, C++, or any other WebAssembly-enabled language. And you can change the logic of your blockchain while it's working. So constantly, while new blocks are being added to the chain itself, you can just switch the logic, and instantly you get the new code that's there. And this is really important because there's no need to do a hard fork, which is operationally very, very hard, especially if your chain is running across multiple organizations. So yeah. And basically, you get so much more. So you get an instant lifeline. So compared to other blockchains, I think it's easiest to make a lifeline, for example, for a mobile phone to connect to a Substrate-enabled chain. You also get chain synchronization. You get to really well documented and verbose PubSub, WebSocket, and JSON RPC API. So you can, again, connect in any language and do custom logic on top of your blockchain. So for example, listening to transactions happening and reacting to that in the off-chain world, let's call it like that. You get the transaction queue. You get very, very secure networking. which I perceive as much better thought out than hyperledgers, for example, but much less complicated to configure. So that's a huge bonus. You get the JS implementation as well. You get something called the SRML, which is the modular MSRM, sorry, which is the modular substrate runtime module library, which I think Filip is going to talk more about. And also you get interchain connectivity via Polkadot, which Ivor is going to talk about. So thank you for listening to this brief intro, and I'm handing over the mic to Filip.
Yeah, thank you, Bogdan. So let me just start the share screen. Yeah, can you see it? Yes, okay. So let's start. This is basically intro to substrate development, or I would like to say like how to start building anything on top of Rust and Substrate without any knowledge. So just for total beginners. So firstly, we should divide our approach in two phases. First one is research phase, and second one is building phase. So in the research phase, we try to learn basic concepts of Rust, and then go deep dive into Substrate and try to know what is the concepts, what is the architecture, and how to actually build something. And third one is like trying to build something actually, and prototyping, building some proof of concept, MVPs, or whatever you desire to build. So first for Rust, I divided in three main like learning phases. First one is syntax. I think like crash course is enough to get you going with Rust syntax. And when you know the syntax, you should probably, next one should be capabilities of the languages. So some small projects, mini projects will do the job. For example, networking, API, chat application, Wasm compiler, REST APIs. Like there is a bunch of projects and tutorials online, so you have materials for that. And third one is a book. So you understand the syntax and capabilities. You've written some code, and now you should probably try to get to know some design principles, and also what is the logic and why Rust is built that way that is built. So I would say that those are three main stuff. So next one is, if I would say, overview of Substrate runtime. So runtime is possibly the best place where you should write your application or business logic, because it can interchange. It's forkless upgrades, as Bogdan already said. So it's a best place to start. You choose your storage, your transaction pool, your consensus, and just try to start to build your code in runtime. So what you actually need to do, like there is frame. I think Bogdan already said like SRML. That is old name, so now it's frame. And you inside the frame, you should choose like palettes that you need. For example, system, timestamp, pseudo, grandpa balances, whatever you want. So, and when you choose, you integrate them in a runtime and you start. So first one is palette. So palette, imagine it like a module on Substrate. So it's part of the code that is running, and you can communicate from outside the world to that palette. So in order for you to implement the palette, every palette needs to have a traits. It's Rust interface based, if I would say, Rust interface. Second one is declaration of the storage. So you can imagine that your module is not run directly on top of operating system, but rather on top of blockchain. So when you're storing something, you're not storing it from pointers to the memory, but rather you're storing to the blockchain storage. So what Parity guys did, the Parity developers, they wrapped in some kind, if I would say, middleware function, how you can declare your storage in order for us, the developers that are building some application, to make it easier for us. Second one is declaration of event. So it's really similar to Ethereum. So whenever something happened on blockchain, outside world need to know what that transaction did, and this is basically where we declare our events and in order to trigger inside our implementation. Third one is declaration of error. So same thing basically from event, but something that happened wrongly. For example, underflow, overflow error. And last but not least, this declaration of your module, where any logic, any functions, anything that you want to actually, any core of your palette is built there in declaration of module. So as you actually have many palettes and you choose like 10, 20, whatever you want, you now want to actually integrate them together in one node or one, if I would say, private node blockchain. So how you do that is basically running construct runtime macro or middleware, where you introduce every single palette that you want to use, and also implement their traits, and also parameterize any constant stuff on your blockchain. For example, read time, write time to the storage, or whatever you actually your own palette or system utility or other palettes need. So now that we know a little bit how Rust and Substrate is working, we're ending up on a turning point for your, if I would say, development. So the question arises that what you want to build. So if you want to build a new private blockchain, the good starting point is Node template. So you start there, try to know a little bit about every single palette, try to understand how they implement stuff and how to actually use their implementation. Or second one is if you think that something is missing, or that your application, your business should not use some implementation of palette, or it needs new features, you should start from palette template and try to implement your own application or business logic there. And if you think that that palette that you implemented is going to benefit Substrate repository in GitHub, you can even open source it. Try to get feedback from the core developers, and they can even help you like build it faster and better. And last but not least is community and dev support. So if you have any question, any dilemma or problem that you have, Riot channel is possibly the best place where you can ask that. And there is a lot of community and dev guys that are in the channels, and they can help you pretty much easily. And the response time is not that big, so yeah, that's a plus. And also, if you're willing to open source, the feedback on your code is willingly given by core devs. So, like, when you finish some prototype proof of concept, you can try to ping them. They will probably give you feedback and try to say, okay, you did that wrong, or this can be improved there, or something similar. And when you finish like prototyping, building some MVPs, getting to know Substrate, you can even try to build something new and applying for a grant if you have an idea that is good. Or if you don't have ideas but you know the Substrate and you now learned how to do it, the next thing is to try to find some implementation that is not yet implemented and try to apply for the grant with that. So that's it. Thank you, and have a nice day. So Ivor, I think, is next. Is Ivor in a call now?
Yep, I'm just bringing him back on the screen. There we go.
Yeah, thank you.
Hi, everyone. Oh, sorry. Okay, so do you see the presentation?
Yeah, we can see it.
Yeah. Okay, so hi everyone. Again, I'm Ivor. Nice to have you all. So today we're going to talk about the Kusama network, precisely the Kusama approach. And Kusama, it's for anyone who doesn't know, it's the wild cousin of Polkadot. So why I think Kusama showcase an entirely new concept in the blockchain space, and why it makes sense when people call it the Canary Network and give it such a new name that no one used before. Why it makes sense. So first of all, we need to go back to the summer of 2019 and see what was the state back then. So Polkadot was still in development then, but an early version of the code was ready for some kind of soft launch. We had the Substrate framework, which Filip and Bogdan talk about. It was also ready for developers to start experimenting. And we had a very young community that needed some kind of bootstrap and a way to scale up. So when we look at it and try to figure out what Kusama did and what was the purpose of it, we will see that network created for those kind of things. So to incentivize innovation, to be some kind of pre-production environment for Polkadot, when you can try stuff before going to mainnet. Also building the ground for new business models to be built on top of it. Then, of course, the on-chain governance, which is one of the main focus of Polkadot and Kusama, of course. And at the end, building the community, integrate with other projects, and building the ecosystem. So let's try to see how Kusama achieve all those things. So first of all, that is very important and very interesting is the economic sense of the network. So Kusama have its own native token, which named Kusama. And 1% of DOT tokens at Polkadot Genesis should be reserved for Kusama. So in that way, Kusama has a value at the beginning of the network. And of course, every DOT holder will get the same amount of Kusama for the dots. So when we look at it from this point, we'll have the four main use cases for the token. And those are the transaction across parachains, then bonding parachains, so deploy your own and paying for it, governance, voting, proposals, referendums, and at the end, staking, which is maybe the most interesting because there are dozens of projects doing staking with their own business models, bringing new value and bringing economic sense and meaningfulness to the network. Another very important thing and one of the main focus are the governance. So let's try to see the launch process and how we move to on-chain governance. So it all started with the proof of authority network, where the Web3 Foundation hosted the validator nodes of the network. Then in a couple of months, we moved to nominated proof of stake and had the first validators election. After that, also, it took a couple of months, some time to get everything settled down. And then we have the governance, an on-chain governance, where everyone could propose something and go to referendum, decide, and choose the direction of the network. And at the end, after a couple, again, months, the governance decided that they want to remove the pseudo keys of the network, and from then on, the governance runs the show. When we try to look on some stats, we can see that Kusama is one of the most staked and active DAOs in the space, with more than 150 Kusama tokens, 150,000 Kusama tokens in treasury. Also, it has a shorter time. When you look at Polkadot and other networks, a shorter time of proposals and voting, which lead us to a faster decision-making and frequent upgrades on the network. One more thing that could be interesting to the governance and has to do with it is the identity. So we can see that on Kusama network, it's maybe one of the first proven personal information identity in the space, where you can set some personal information of yourself, and some kind of authority on the network will validate if they're right or not, or maybe they don't know still. But it's also some kind of identity on the network. And it's also lead us to features like a social key recovery, where you can choose some of your friends or family members on the network and give them the power to be the one that could recover your private keys if they get lost. Then again, maybe the most important thing and the purpose of Kusama is the innovation. So how they incentivize it. So you can, as a user, build parachain and deploy application in Kusama. You can use the new framework for building blockchain from scratch, Substrate. Then again, experiment with all of these, try new things, get feedback from the community. And at the end, you have the option of on-chain forkless upgrades, which lead us to newest features as soon as possible on Kusama. Here on the picture, you can see the entire ecosystem of really a large number of projects of Kusama, from validators to wallets, then explorers, infrastructure projects, and etc. Another thing that I want to point out is the idea of the level of blockchain. So when we think of it, we have three networks under the Parity and Web3 Foundation umbrella. And those are Polkadot, Kusama, and Westend. So Westend is the last one, and it's, let's say, a classical testnet, let's say like Kovan on Ethereum and those kind. So when you think of it, you have a different kind of networks which give you a different level of security controls, features, but again, will have a different kind of pricing for using it. So it wouldn't surprise me to see in the future that another layer one solutions will give you the opportunity to choose if you want to have a very comprehensive approach, let's say enterprise, which would be Kusama in this case, or at the other hand, something that is totally free when you can try fast your code, which would be Westend in this case, and Kusama would be something between those two. But again, it could be possible in the future that you have more and more levels of blockchain. So let's try to think what would be the case when Kusama is the right choice for you. So maybe it could be some kind of situation when you want to build a game where you're a young couple of developers, young team that want to try to deploy a game to the network. So you want to deploy your own parachain, but you want to have a lower bonds because you are a young team. Fast iteration and the latest technology of the network, and of course validate your idea as soon as possible. And at the end, that could be some kind of a step before going to Polkadot, where you want to scale and have much more security. Let's say another example of a usage would be, let's say, a social network or some kind of those solutions. So from this point of view, after years from launch, we can say that Kusama definitely achieved their goals. Kusama is here to stay, and probably, as everyone thinking, it will become one of the first bridges on Polkadot. One more thing that is very beneficial from the Kusama network is the experience that we have with the launch process, and now we can see that Polkadot will follow mostly the same steps during launch, and when you have this kind of experience, you can do it with much more confidence. Of course, we can expect more networks like Kusama in the future from other projects for layer one solutions. And at the end, it remains to be seen how Polkadot would outreach its white cousin who put a very high standard. So yeah, that's it. Thanks, everyone.
Yeah, we should probably answer some questions now.
Oh, yeah.
I can bring Bogdan back on and.
So yeah, if you have any questions, there is like ask a question part in bottom right of the screen. So feel free to ask any. So
okay,
let's start with the first one. So to run Substrate development environment, is needed to run at least 2 nodes. No, actually, no. I think it's only needed to run 1 for development purposes, of course. But if you're willing to run private chain, staging environment, or whatever, probably it should have more than 2, like 3, 4, whatever. Do you have some ideas for small improvements, tool for Substrate or Polkadot? I think there is the whole GitHub repo on Parity. That there is like some proposals or whatever, but let me try to search it so I can maybe find it, but never mind.
Okay, is the next one what Kusama means? So I suppose I think I heard somewhere it's the name of some Japanese singer. Then maybe you can.
No, I think it's Yaoi Kusama, or I might be mistaken. He was, I think, a sculptor or something like that in Japan, who was also obsessed with about pumpkins or something like that. Yeah, an artist. Yeah.
Okay, so that one is answered too. On-chain governments mean no forks. I would say no. Governance deciding what would be the upgrade of the system. So, but there is no possibility for forks, but that not directly a consequence of on-chain governance.
Yeah, but you can always change any implementation of any business logic with upgrade of your runtime. So you can change code, but if you want to change some state on blockchain, you can do that with democracy palette. So that is basically on-chain governance.
That, and also if you're maybe referring to the currently Genesis governance that's deployed to Kusama, that is to the 3 legislation modules that are running. That's the most powerful one when it comes to administrative stuff, and it's the one that needs to whitelist all of the changes right now, if I'm not mistaken.
Yeah. So
do you want to come onto the screen? Your video.
Sorry, I didn't hear you.
Do you want to bring your video on so people can?
Sure.
Cool.
Yeah, so the next one, for holding 1 dot, how many people get Kusama? So 1, the same person that have those dots get the same amount of Kusama on their Kusama address. So yeah, it's 1 to 1. So could you describe how the transition from validator to nominator, etc., works? So as I figured it out, it was a process of first of all giving the governance the power to choose and deciding and elect the validators, and then from then building the whole and deploying the whole logic behind staking and nominate new validators and growing up all the community of validators. Okay. This is for Substrate.
Yeah, next one is it possible to create Substrate address via UI or just only via CLI? So I already like posted a link. There is a website, so you can like communicate with every palette and also create new accounts and do whatever you want on like account base. So you can add new account, restore it, whatever. So yeah, there is.
And this comes with when you run the node template for Substrate. I think it comes with this particular front end as well. So when you're developing locally, you get that as well.
I suppose that the next one is also for me. Template of the game. I have to admit that no. I just thought it would be an interesting solution, an example, but I didn't find one. I'm for sure that there are plenty of them, but I didn't find. And at the last one from Vuxan, can anyone explain in short why would someone choose Kusama over Polkadot? So yeah, I try to explain it through the presentation. So it'd be smaller barrier to deploy your parachain. Then again, smaller pricing for bonding and things like that, and have a faster iteration because the governance choosing about proposal much shorter than Polkadot. So yeah, those would be some kind of the good side of Kusama over Polkadot. And I think that's the last one. So yeah, I don't know if Dan is still with us, but thanks for everyone to. Yeah, you're here.
Yep. Does anyone else have any questions for the three of them while we're still on?
Yeah, it seems that.
Okay, you sent your email. Any other like links or ways to get in touch with you guys that you'd like to give to people?
Of course, but I think my teammate also already shared some. So yeah, but we'll share it here on the chat. So yeah, thank you to everyone. I hope you enjoyed. This was our first meetup. Next time, of course, to meet everyone in person and have a beer together after it.
Yeah, thank you all.
Thank you.
Thank you all.
Thanks
Bye
everybody.
bye.
All right.